Hey everyone, welcome back to the channel. Hope you are doing extremely well. So today we are going to solve the problem merge two sorted linked list. So the problem basically states that you'll be given two sorted linked list and you have to return it as a new sorted list. Now the new list should be made by splicing together the nodes of the first two lists. Now what it means is you're given 1, 2, 4 and then another sorted list as 1, 3, 4. After that you have to make it a single linked list such that it is sorted in itself also. Like at first this one will go, so it goes. Then this one will go, it goes. Then who is the smaller one? This 2, so it goes. Then who is the smaller one? This 3, it goes. Then this 4 goes. Then this 4 goes. So you can see that the merged linked list is also a sorted one. Now why is this problem under this easy section? The reason is they're asking you to make an entire new linked list, but we are going to solve it for both the problems, that is you make an entirely new linked list as well as making it in place. Like 1 is going to point to 1, after this one is going to point to this 2, after this 2 is going to point to this 3 to this 4, and this 4 to this 4, basically in place. I'm not going to use any external linked list to use it as an answer. So if you are in an interview, the interviewer will simply give you the problem. You're given two sorted linked list and you need to merge them into one sorted complete linked list. Now the interviewer is not going to tell you whether you need to do it in place or you can use some external space. So obviously if you are in an interview and you get this question, the first solution that you give to the interviewer should be of the external space solution. So what we do is we keep the head 1 pointing to 5 and we keep the head 2 pointing to 3 initially. And what we do is we create a dummy node, right? We create a dummy node over here, which will be initialized to 0 and null. And after this, what we do is, what is the smaller one of 3 and 5? So we see that 3 is smaller. So what we do is we create a new linked list and insert the node value 3 into that linked list. And after this, we point the next of the dummy node. Remember this, we point the next of the dummy node to 3 and we move this dummy node. Since we require the head of the merged linked list, we can create a duplicate dummy node. So what we do is we move our duplicate dummy node. Basically, we keep our dummy node over here and we're going to move this duplicate dummy node. So once you have taken 3, so we're going to move this head to 4. Now, who is the smaller one of these two, whether 5 or 4? So we see that 4 is smaller. So what we do is we create a new node which will have the value 4. Right, and after that our duplicate dummy node is gonna point to this 4, and after this we are gonna move this duplicate dummy node to 4. Now once we have done this, since we took 4, we can simply move our head to 8. Once you are done with this, who is the smaller one of 5 and 8? We can say that the 5 is smaller. Now since 5 is smaller, we are gonna create one more new node and we are gonna assign this 5 to it. Once we have assigned that, what we do is again we point the next of the duplicate dummy node to 5 and we are going to move our duplicate dummy node to 5 now. Now remember one thing, we are using external space, that is we are creating new nodes. After the step, we are going to move our head 1. So our head 1 is going to reach 7. So the moment the head 1 reaches 7, you again start comparing 7 and 8. Now who is the smaller one? Obviously 7. So we are going to create one more new node which is going to keep 7. And after this, what we are going to do is we're going to point the next of the dummy node to 7 and we're going to move our duplicate dummy node to 7. And since we took 7, we're going to move head 1 to 9. After this, we're going to do a comparison between 8 and 9. So we see that 8 is the smaller one. So what we do is we create one more node and we assign 8 to it. And after this, again the same step, we assign the next to 8. And then we move our duplicate dummy node to 8. And since we took 8, our head 2 is going to move to 10. After this, we compare 9 and 10. So we have to take 9. Again, we create a dummy node and we are going to take 9. Again, the same set of steps. Point the next to 9. Move our dummy node to 9. And since we took 9, move our head 1. So our head 1 is going to point to null. So the moment it points to null, you're gonna stop. And after this, the remaining portion, that is this, just copy paste it. Basically, if there is 10, you create one more dummy node which assigns 10 to it, and the next of this duplicate dummy node is going to point to 10. And after this, you're going to move this duplicate dummy node to here, and after this you're going to move this head 2. So now our head 2 is going to reach null. So the moment it reaches null, you're going to stop, and you're going to point this 10 node to null. So once you are done with this, you completely stop. So what I can say is, our dummy node, right? Our dummy node was this. So what is the head of this entire new merged sorted linked list? We can say that the head is dummies next node. So we can simply return dummies next, because that is going to be our head of the new sorted linked list. Now, since linked list follows address, even if you take duplicate dummy node and create nodes, since you have connected this, that means the dummy node will be connected to this chain only. Now, if I talk about the time complexity, what I can say is, I traverse this first node entirely. So I can call a big O of n1, that is the length of the first linked list. And then I traverse this one entirely. So I can call it n2, basically the length of the second linked list. And what about the space complexity? Again, it's going to be big O of n1 plus n2. The reason is because I use an external space to create an external merged sorted linked list. Now, if you're not coding this in lead code, and if you are in an interview, the interviewer is for sure going to ask you to optimize the space complexity. So the next step is you're going to do it in place, that is a big O of 1 space complexity. Let's see how. So before we move on to the next approach, I wanted to introduce you to something very big. Now, Unacademy has tied up with CodeChef to launch competitive programming on their platform. In this platform, you'll be learning from different educators. Now, these educators are world's best programmers who have been to ICPC World Finals. Also, they have won medals at IOI, and some of them are also working at the top product-based companies. So currently, Unacademy is hosting a lot of free live classes on their platform, so you can probably try them out. Along with this, they have come up with a subscription plan. Now, in this subscription, you'll be getting interactive sessions. Now, this means they'll be having live classes where you can interact with the educators directly in the live class. Along with that, you'll be having structured courses. Now, they will be having courses for beginners, intermediates, as well as the advanced people. So there will be live classes throughout the year. You can join any of the course or any of the class that you feel to join. And there will also be recordings of the classes so that you can watch it again if you want to, of any given live class. Along with this, they're giving you teaching assistants who will be clearing all your doubts that you'll be facing. So the subscription comes up in 3 variants. So if you want to enroll this and you want to get an additional discount of 10%, you can use the coupon code take you forward. Do check it out. The link will be in the description. So if I talk about in place, what does in place solution means? It means this are the 2 given linked list. You don't create any external nodes. You use these nodes to create our merged sorted linked list. How do you do that? You basically take the first small element, that is 3, and that's going to point to 4. After this 4 is going to point to this 5. After this 5 is going to point to this 7. After that, this 7 is going to point to this 8. And this 8 is going to point to this 9. This 9 is going to point to this 10. And this 10 is going to point to null. And all these links will be broken. So this is something which is known as in place, where you do not create external nodes and you do it in place. So let's see the optimized solution for doing this. So at the first step, what you need to do is you need to take 2 variables. Let's call it as L1 and L2, basically list 1 and list 2. That is what I call it. Okay. And at the first step, whichever one is the smaller, remember this, whichever one is the smaller, you're going to point L1 to it. So over here, 3 is the smaller one. So I point the list 1, that is the node, head of the second list as L1. And I'm going to point the L2 to the 5. And after this, we're going to do multiple iterations. Let's see how. So before you start doing the number of iterations, what you're going to do is you're going to mark the result. Okay. You're going to mark the resultant initially to this L1. Okay. So our resultant is going to point to this 3 at first. Now let's start the first iteration. Now in the first iteration, what you do is you create a node temp and assign it to null. I'm going to explain you the intuition behind this. And after this, what you do is you keep on moving this L1 node until it is smaller than this 5. So at first, this 3 is smaller than this 5. So what you're going to do is you're going to move your L1. But before moving this, you're going to assign this temp to L1. So currently you can say that temp is assigned to L1, which is the node with a value 3. After this, you're going to move your L1. So now, still now, the L1 is lesser than 5. So what you do is, you reassign your temp. You reassign your temp to L1, basically the node with the value 4. And you're going to move L1. So this is the moment where you see that this L1 has a value 8, which is not lesser than 5. So that is the moment your first iteration is gonna stop. And since your temp is pointing to the node 4, now remember your temp is pointing to the node 4, correct? So what you need to do is you need to break this link. Because 3, 4, and that should connect to 5. The reason is we know that 5 is smaller than 8. So what we do is simply after the entire iteration, we are going to take the temps next and point it to 5. So basically what this does is, this basically breaks this chain and takes the 4 and points it to 5. Basically the chain is now assembled in such a way that 4's next points to 5. So the work of the first iteration is done right now. Now it's time to start the next iteration. But before that, who is your smaller node? Now I can say that my smaller node is this, because L1 is pointing to 8 and L2 is pointing to 5. So what you do is you swap them. Basically you say that L1 is this now and L2 is this now. And after this, you're going to start your second iteration. Now in the second iteration, you're going to do this exact similar thing. What you do is you assign initially temp to null, okay, and after that you're gonna move your L1 till it is smaller than 8. So I can say temp at first is 5, which is smaller than this 8. So at the first step, temp will be assigned to 5, the node L1, that is 5. What I'm doing is basically remembering which is the last node, which is the smaller one. So it's remembering that 5 is the last node, which is smaller than 8. After that, you're going to move your L1 to 7. Now again you can say that this 7 is smaller than this 8. So what you do is you simply move this L1. But before that, you are telling temp, hey, remember that 7 is the new smaller node, which is smaller than 8. So after this, you're going to move L1. So the moment you move L1, what I can say is, now our 9 is greater than 8. So what I know is, what was the last node that was smaller than 8, that is 7. So I can say, I started from 3, 4, 5. So the link is going correctly. 5 should point to 7. But should 7 point to 9? No. To which one should it point? Your temp is standing here. Remember this. So it should point to 8, isn't it? So what you do is, you just point temp's next pointer. That was this. But you're going to break this and you're going to point it to 8. So now it points to 8. After this, your second iteration can be said as over. Now what you do is, L1 is always going to be the smaller list and L2 is always going to be the larger one. That is when you start the iteration. So for the third iteration to start, what you can say is, hey, L1 is going to be 8 and L2 is going to be 9. Basically, I swap every time I start an iteration. So in the third iteration, what I do is initially assign temp to be null. And then I compare, is this 8 smaller than this 9? Yes, it is. So our temp gets replaced by L1, that is the node 8. And what we do is, we're going to move this L1 to the next one. That's correct. After this, when you start comparing, very important, when you start comparing 10 and 9, you see that 10 is greater. So this is the moment you can say that this link is wrong, because 8 should not point to 10, because 10 is not lesser than equal to 9. So since you stored temp to be 8, you can simply point your 8 to L2. So this is how the link will look like. And after this, you can say your third iteration is over. So what do you do in the next iteration? You swap linked list, right? So L1 is going to be this and L2 is going to be this. So in your fourth iteration, at first, again you're going to take a temp variable which will be initialized to null initially. And after this, you're going to compare your value of L1 to 10. So you see that 9 is still smaller than 10. So what you do is you assign temp to L1, that is the node 9, and you're going to move L1. So the moment you move L1, very important, it's over. Yes, it's over. The moment you're going to move L1, it's over. And the moment it is over, what I can say is, okay, our temp is now standing at 9. This 9 has to point to 10. Then we can actually get that sorted linked list. So 9 currently is pointing to null. So what I take is, I take the 9 and point it to L2. So basically every time what I do is, I point out temp to L2. So what I can say is 9 now points to 10 and 10 will automatically point to null. And this L1 is going to be null. So the moment L1 becomes null, you're going to stop then and there. So you can see our resultant, which was pointing to 3, correct? That is now pointing to 4. Now 4 is now pointing to 5. 5 is pointing to 7. 7 is pointing to 8. That's to 9. That's to 10. And that's to null. And that is your linked list. Now since you stored the resultant, you can easily return the head of the sorted linked list. And what you did was, you did it in place. You basically broke the bonds and you had a new links connected to these linked lists. So if I talk about this time complexity, it still stays n1 plus n2, where n1 is the length of the first linked list and n2 is the length of the second linked list. But the space complexity, since we are not using any external nodes, we are using the nodes which are given to us, I can say that the external space used is big O of 1. I think now it's time to discuss the C++ as well as the Java solution. So in the Java solution, as you see, what we are given is the first linked list L1, the second linked list L2. And at the first step, the easiest thing you need to do is, if the first linked list is null, you know that the second linked list will be your answer. And if the second linked list is null, the first linked list is going to be your answer. Now if you remember, what we did in the first thing is, we assigned L1 to be the smaller one and L to be the larger one. So if by any chance the linked list 1 is having a first value greater than L2, what I do is I basically swap L1 and L2, so that L1 will stay as the smallest one and L2 will be the one with the larger value at the first iteration. Now initially we kept our result to be pointed to the smaller one, that is L1. So this is what we do over here. At the next step, we know we are going to do iterations till either of L1 or L2 reaches null. And after this, what we always did was, we assigned a temp to be null. Once we have done that, we simply did iterate L1 till it was not null until the value was smaller. And how did we iterate? While iterating, we assigned L1 to temp, basically to remember which one was the last node, so that we can create a connection. And after that, we moved L1. Now after this entire iteration is over, what I can say is, temp will be pointing to the last node, which is still the smaller one, and we can easily point temps next to L2. This is what I do. And after that, I'm going to swap L1 and L2. And once we have completed the entire iteration, what I can say is, I have done the in place merge of two sorted linked list. It's time to discuss the C++ solution. So in the C++ solution, you can see that you're given linked list L1 as well as you're given linked list L2. Now, what are the edge cases? Obviously, if the first linked list is empty, the second linked list will be your answer. And similarly, if the second linked list is empty, the first linked list will be your answer. And the other thing that we always did was, if the linked list 1 was greater, we basically swapped it. So that is what we do. Initially, before starting, we see that L1 is going to be the smaller one of the linked list, having the first value smaller. After this, we are going to assign result to L1, that is the first linked list. That is what we did to basically remember the head of the merge sorted list. After that, we are going to iterate till either of L1 or L2 reaches null. Right after that, what we do is we assign temp equal to null for every iteration. And then we're going to iterate for L1 till it doesn't reaches null, or if the value is still lesser than equal to L2's value. We remember the node in temp, and after that we are going to move L1. So since we remember the temp, that is basically the last node which is smaller, we can simply point it to L2 to have a new connection and break the old one. And once we are done with this, we know we have to swap L1 and L2 before every iteration. So we do it before the next iteration. So once the entire iteration is over, we can simply return res because it would be pointing to the head of the newly merged sorted linked list.